Here's what's different with secant, cosecant. Their period is 2 pi. So you notice down here, the period is 2 pi. But check this out. This is what's very helpful. When you look at this image here, and I know it's a little blurry. I'm sorry about that. When you look at this image, though the period is 2 pi, halfway across the period, you happen to have an asymptote. So you still have an asymptote every n pi. So I want to be very clear. The period is 2 pi, but we have an asymptote every halfway point. So when we solve this, it actually will not change step 3. We're still going to say plus n pi. So here's cosecant and secant. So again, here's a picture. Let's solve it out for the vertical asymptote. Step 1, and let me get a calculator up here. There we go. Step 1 is the ratio. And so the ratio for secant is h over x. Because I'm looking for a vertical asymptote, that occurs when in math when you divide by 0. So I need to search for when x equals 0. So if you haven't put this together already in your head, you might be thinking we've done when x is on the denominator, but it wasn't secant. That's right. Tangent and secant are going to share the same asymptotes. Tangent and secant will share the same asymptotes. I'll show you this graphically in a second because they both have x in the denominator. So on this one, x equals 0 at pi over 2. Again, there's other spots, but I'm just choosing the first one. Oh, let me color coordinate like I've been doing all class. Pi over 2. So on step 3, when I go to horizontal transformations, specifically apply my horizontal transformations, I start with the pi over 2, and I'm also going to have the n pi plus n pi. And so now I just ask myself, the horizontal, those are the ones connected to the x. What's that 2 doing there? What's the 2 doing to the x? Multiply, but x's are liars, so we're not going to actually multiply, we're going to divide. So I'm going to have pi over 2 divided by 2 plus n pi divided by 2. And I'm going to reduce this for you right here. You could go to Desmos and type in 1/2 divided by 2, and you'll get 1/4. So I'm just going to tell you, it's going to be 1 pi over 4 plus n pi, not 2n pi, here we go, n pi over 2. And again, this is where n is an integer. And that would be my solution. So visually, that means the first one occurs. This is where n equals 0. This would be, whoops, x equals pi over 4. And I'm not going to write them all out here just for the sake of time. Since you see me do this, this would say add half a pi, which it's like 2/4. So from 1/4, add 2 more quarters, I get 3/4 pi. That means this one right here would occur when x equals pi over 4 plus 1 pi over 2, which is congruent to 3 pi's over 4. That's when n equals 1 right there. That pi would be 3 pi over 4. That would be the next asymptote. And you could go on and on and on around if you wanted to. That's pi over 4. And that's 3 pi over 4. That's how they work together. Okay. Graphically, what I want to, before I move on, I do want to show you this. What I was just saying is now that we have this graph up, I will show you how tangent and secant, where's my secant, will always share an asymptote. This is cool. So just so I don't have to change equations, I'm just going to do this one over 4. So if you have the same b, you'll notice, look how the transform, you see how that asymptote works for both of them? It doesn't matter if it's secant or tangent. If you have the same transformations going on the inside, they will share asymptotes. Why? Because both secant and tangent have x in their denominator, which implies that if tangent and secant share asymptotes because they both have x, that implies that cosecant and cotangent will share asymptotes because they both have y in the denominator. So little neat how math works together there. So here we go, last one for you. Let's take a look at example 4. It says locate the vertical asymptotes and sketch this graph. Again, here's the sketch. Let's go through the steps together. Step 1, we look at the ratio. So the ratio for cosecant is shown right here on the left. It is h over y. Now to have a vertical asymptote, mathematically that occurs when you divide by 0. So I need to solve for where y equals 0. And to do that, I use the unit circle. It's a very helpful tool. So the unit circle, y equals 0 at, let's go find out. So I'm looking at y values. It's not going to be pi over 2. That's when y is 1. Y equals 0 on the x-axis, which means I could use these 2 points, either those two or pi. I'm going to choose 0. It's the easiest number to work with. So I'm going to say it's 0. Whoops, let me color coordinate here. We'll go blue. Okay, so now what do? I apply my horizontal transformations. So what do I have? I start off with x equals this 0 plus n pi. There I am without transformations. On this one, notice my b is 1. I don't have a b doing anything. However, I do have a c value. My c is pi over 3. It's adding. What is the opposite of adding pi over 3? Subtracting. So we just need to subtract pi over 3. This problem is really simple because I have a 0 up front. So I'll just skip all the way to my red that I want to use. It'll be negative pi over 3 plus n pi. That's, forgot n is an integer. That's what NEZ means, where n is an integer. So positive or negative whole number is all that means. So that would tell me that this right here, negative pi over 3, that would be my first asymptote, negative pi over 3. That would be when n equals 0 right there. And all of them are found after using that formula. This would end up being, since I'm adding a whole pi, this would occur at 2 pi over 3. Yeah, 2 pi over 3. That would be 5 pi over 3, 8 pi over 3. That's how it goes across if you use a common denominator. What I just did there is I got a common denominator. I was adding 3 over 3 each time. So from negative 1 pi over 3, it became 2 pi over 3, 5 pi over 3, 8 pi over 3, so on. So that's what I did right there. All right, let's check this out. Your last DOL, I want you to solve this problem here.